Let's take a look at number 26. So this is section 4.4 exercise. Actually, let's do 24. So exercise 24. And in this exercise, we have our integral from 1 to 4 of 3 minus the absolute value of x minus 3 dx. Well, so to get this one and get the antiderivative, I actually need to think about this absolute value. And so we have the absolute value of x minus 3 is equal to, well, it's the negative of that, so it's 3 minus x whenever x minus 3 is negative. Okay, so when x minus 3 is less than 0. So we'll have to decide what that means. And then x minus 3 when x minus 3 is greater than or equal to 0. Okay, so, well, that's up here. We have the 3 minus x when x is less than 3, and x minus 3 when x is greater than or equal to 3. Okay, and so we have to rewrite this integral as the integral from 1 to 3 of 3 minus the absolute value of 3x dx plus the integral from 3 to 4 of 3 minus the absolute value of x minus 3 dx. And so then we toss in our definition. This is the integral from 1 to 3, and we have a 3 minus x, so this is 3 minus x. Be careful again with negatives. Plus the integral from 3 to 4 of 3 minus x minus 3 dx. And so this is the integral from 1 to 3 of x dx plus the integral from 3 to 4 of 6 minus x dx. Now we're ready for the fundamental theorem of calculus. We have x squared over 2 from 1 to 3 plus 6x minus x squared over 2 from 3 to 4. And so this is 9 over 2 minus 1 over 2 plus, we have 6 times 4, that's 24, minus 4 squared, so that's 16 over 2, and then minus with the 3, so that'd be 18 minus 9 over 2. So there we used our fundamental theorem of calculus. 9 halves minus 1 half is 8 halves, or 4, plus 24 minus 8, so that's 16, and then minus, well, I think actually it'd be easier, a little easier for me if I did minus 18 plus 9 over 2, because then that makes a negative 2, so I have a negative 2 and a 4, so that's 2 plus 9 over 2, and that is 4 over 2 and 9 over 2, 13 over 2. Okay, so the big thing there is to work with those absolute values to get that problem right. So, okay, that was number 24.